So here we are seeing something about Sutherland-Hodgeman Polygon Clipping algorithm, where what we have seen, what we try to understand is polygon is a list of vertices. Suppose we have v1, v2 to v6, then a polygon can be represented by connecting all these points together, and whatever area is within the polygon, that is the area within the polygon. Now if we have a window and we want to perform polygon clipping, it means whatever the portion of the polygon comes inside the boundary of the window, it needs to be displayed. So for that, normal line clipping algorithm is not helpful. We need to have a new algorithm. We call it Sutherland-Hodgeman Polygon Clipping algorithm. In this example, as you can see, this area which is enclosed by v1 dash, v2, v3 dash, and suppose it is v5 dash. So this portion should be displayed and the rest portion of this polygon should not be displayed. So for this, what this Sutherland-Hodgeman Polygon Clipping algorithm suggests is very simple. We have a window and we have the boundary of the window. At the same time, we also understand that this polygon also has a boundary. Boundary is v1, v2, v3, v4, v5, v6. So on the boundary there are multiple lines, a line from v1 to v2, line from v2 to v3, v3 to v4, and so on. Having understood this thing, what we will try to understand is how can we utilize that information of line clipping and use it here to find out, to perform the total polygon clipping. Okay. So now if there is a line, there are two endpoints, means two vertices if they are. So these two vertices will act as two endpoints of a line. Now for this particular line, there are certain options. Either the line is going from outside to inside to inside, or inside to outside, or outside to outside. These four combinations are possible, right? Let me repeat it. There are only the four cases. What are the four cases? The first case, the line is going from outside to inside. Suppose the line is something like v1 to v2. The line is going from outside to inside, means the first vertex was outside and the second vertex was inside. In that case, what you need to do is, you need to find out its intersection with the boundary, and whatever the position of the boundary it is, suppose it is v1 dash, so you need to add v1 dash as well as v2 to the list. So now you are making a new list for the polygon, list of vertices for the polygon. So here you will add v1, v2. Okay. Now let me repeat one thing, that this thing that we are going to find, the four cases for the lines, we will have to do this with respect to one window boundary, with one window boundary at a time. Okay. So in a way you have to understand that these four cases that we are evaluating here, these four cases we will have to evaluate 4 times for each boundary. I should say with respect to each boundary. So starting from here, the first, let me repeat this thing what I said, These four cases that we are trying to see, that whether the line is going from outside to inside, inside to inside, inside to outside, or outside to inside, outside to outside. So all these four cases we will have to evaluate against each of the four boundaries of the window. Okay. Now which line we have to evaluate? We have to evaluate each and every line of this polygon. In this polygon, if you try to see, you will have 6 lines. So all these 6 lines need to be evaluated against the 4 lines, 4 boundaries of the window. Okay. Okay. So now, so you have added B1, B2 here. Then the next line, suppose it is, the line is from inside to inside. In our case it is not the case, but suppose it would have been the case that for some polygon the line is from inside to inside only. Both the ends of the line are inside the window only. In that case, what you need to do is, you have to understand that one of the line V2 would have been inside earlier. So the second line, the second point, I should say, second line, no? The second point, okay, suppose we are evaluating V8 and V9. In that case, if it is the case of inside to inside, then V9 needs to be updated or appended in the list, because we believe it is inside to inside. So once we have already reached inside, V8 is already here. Okay. Now, okay, the third case is, we are going inside to outside. In inside to outside, what is happening? We have the list V2, V3. Okay. Here we have a case of this type, V2 to V3. We are going from inside to outside. In that case, what we need to do? We understand that V2 is already there. We need to find the intersection of this line with the boundary and keep it. Oh, wait a minute, what we are doing? We are testing these 4 conditions against any one single boundary only of the window. So at a time we need to test it against any one of the boundary. So here, if we are testing this lower boundary, I should say this boundary may represent the bottom. So if we are testing against the bottom, so let me show you the extended view of this boundary. In this case, what is happening? You are having this position V2 as well as V3 both inside. So the line is from inside to inside for this boundary. So in this case, for this line V2 to V3, what is happening? V2, V3, the line is inside. So V2 is already present. Let me also append V3 there. I believe this will be easy to understand, that this case V2 to V3 is the second case, inside with respect to the lower boundary. And for this case, for first round, I should say, for first iteration, we are checking against one boundary, which is the lower boundary only. Later on we will check for another boundary as well, and we will see whether it is inside the boundary or not. For now, V3 is inside the boundary. Now, the next case we were thinking about inside to outside. However, V2 V3 is not the case for this, but I believe V2 now V3 is there, V3 V4 will be a case of this. In this case, if V3 V4 is crossing the boundary, which means V3 is inside the boundary and V4 is outside the boundary, in that case, whatever the intersection point is, we have to consider these intersection point and store it. Suppose this intersection point is V4 dash. Okay, so we need to keep this V4 dash only in the list. Okay, now the other case will be outside to outside. Like the other nodes, you see V4 V5. Okay, V4 V5. This line is totally outside of the current window boundary, which is the bottom. Okay, it is totally outside. So in this case, we need not to consider V4 or V5. Similarly, this case V5 V6 will also be similar. V6 V1 will be also similar. Okay, so in the list somehow V1 V2, so here I believe you are having V1 dash, right? V1 dash V2. So somehow now you have got these four vertices, V1 dash, V2, V3 dash, V3 totally, V3 and V4 dash. Okay, so the new polygon that you are having now is this portion. Okay, so this is what you have got after checking these four conditions with respect to one boundary of the window. Now you need to check the same four things for all the lines of the polygon with respect to the other boundaries. So if you will see with respect to this boundary, left boundary, you will find all of these points, whether V1 dash, V2, V3 and V4 dash, to be inside. Similarly, if you will consider this upper boundary, if it is, then you will find that all of these four, V1 dash, V2, V3 and V4 dash, are inside the boundary. Now if you will consider this right boundary, then you will find that these 2 points V1 dash, V2 are inside the boundary. However, this line, when you will consider V2, V3, then you will have to find an intersection here, which is V3 dash, and you will store it. So the new list will be something like V1 dash is there, V2 is there, and V2, V3 dash, and then the other line V3, V4 dash is totally outside the boundary. You will leave these two. Then the next line is V4 dash, V1. So V1 is inside the boundary, V1 dash is inside the boundary. However, V4 dash is outside the boundary. Which boundary? This boundary. Okay, so you will find the intersection point. Let us suppose this point is V5 dash. So you will store V5 dash here. Okay, So in this way you are getting these vertices. So this will represent your portion of the polygon which is coming inside the window and which will be ready to be displayed. Any question? What we discuss is the limitation of Sutherland-Hodgeman algorithm, where if we get a convex polygon, in that case this Sutherland-Hodgeman algorithm works fine. However, if we get a concave algorithm a concave polygon, in that case this Sutherland-Hodgeman algorithm may not work correctly. What may happen that if for such example you suppose two separate components should be there in a output, using this Sutherland-Hodgeman algorithm you may get these two components connected at somewhere. So you can also make certain changes in Sutherland-Hodgeman algorithm to detect such lines and not to include them, right? You can do this by some of the ways. One way was to split this concave polygons in two or more convex polygon and then apply your Sutherland-Hodgeman algorithm. Or the other way is, after finding this solution, if you are getting a line, means the two endpoints on the boundary of the window, then that particular line should not be drawn. That can be a possibility. Also another possibilities can be moving through the polygon lines and noticing that we are going inside the boundary, we are coming outside the boundary, we are again going inside the boundary. So if such thing happens that you are coming outside and inside, in such cases the line should not be drawn. Such kind of things you can consider, and multiple options can be there for this thing. And these are on the basis of information that multiple algorithms, such algorithms have been published for this purpose. So this was all about polygon clipping. Is there something else that you want to discuss?